All right, so we are going to focus on the domain and the zeros of rational expressions. So if you think back to the intro video, we saw the definition for domain and zeros, and there were some helpful hints. So I'm just going to talk about those off on the side. For the domain, basically, you want to remember that the denominator cannot equal 0. And you solve for your variable to see what values cannot equal 0. For the zeros of a function, that's when you figure out when does the numerator equal 0. And you solve that. So remember, domain, denominator, perfect. They go together. They're both D's. So domain goes with the denominator. You cannot let the denominator equal 0. The zeros of your function go with the numerator, and you want to know when does the numerator equal 0. All right, so let's give this a try. Example 7, we have the function y divided by y minus 4. So the domain, remember we take our denominator, which is y minus 4, and we say it cannot equal 0. And then we go ahead and solve for y. So you would add 4 to both sides, so you say that y cannot equal a positive 4. So remember, domain has to do with your x values, so even though our variable is a y in this problem, when we state the domain, we're going to switch back to x's. So remember, domain is all of the x's such that x does not equal 4. So we have a different variable, because remember, you can use any variables, but domain is tied to x's, so remember to switch back to x's for our answer. All right, now the zeros of your function is you're going to take your numerator, which is a y, and you're going to set it equal to 0 and then solve. Well, that's already equal to 0, so the 0 of our function is just 0 because it's this value right there. So our domain x cannot equal 4 and the 0 of our function is 0. Remember, the 0 is what number would make the entire function equal to 0? Well, if this is a 0 up here in the denominator, isn't 0 divided by everything equal to 0? So that's why we got 0 for that answer. Zeros will not always have an answer of 0. That was just a coincidence on that one. All right, example 8. Find the domain, find the zeros. So the domain, remember, has to do with the denominator. So we're going to say y squared minus 16. The denominator cannot equal a 0. So now we're going to solve this, and if you remember, this is that difference of squares. This can factor into y plus 4 and y minus 4, and then does not equal 0. Now that it's factored, we set each factor equal to 0. So y plus 4 does not equal 0. Y minus 4 does not equal 0. So y does not equal, if you solve the first one for y, you get a negative 4. Solve the second one, you get a positive 4. So now when we write our answer, we say, that's great we were using y's, but domain is x's. So domain is all your x's such that x cannot equal a positive 4 and a negative 4. And the order that you write this does not matter. All right, so that was our domain. Now let's talk about the zeros of our function. The zeros is when you take the denominator, which is y cubed plus 3y, and you set it equal to 0. Because if this numerator is 0, 0 divided by anything equals 0. So we have to figure out what values will make that equal to 0. So again, this whole chapter is on factoring. So we're going to factor and solve. I see these have a common factor of y, so I'm going to take a y out, and we get y squared plus 3 equal to 0, and then we solve each one. Set these factors both equal to 0, so you get those mini equations, y equals 0, y squared plus 3 equals 0, and solve each one. So this one's already solved. This one, when we solve this equation, it's not a difference of squares, so we can't do what we did up there with the plus and the minus. We just go ahead and get this 3 on the other side. So we have y squared is equal to negative 3. And then we square root both sides to undo the y squared, and this is where we get stuck. Can we square root a negative 3? And no, we cannot do that. So we actually don't get a 0 from this little equation. So we did get one from this one, however. What is the 0 of our function? It is 0. And I know in the last one I said it won't be 0 every time. Looks like it's another 0, but it really won't be 0 every single time.